So we left off last week, we were talking about converting percents to decimals and percents to fractions, and the other way around, fractions or decimals into percents. And when we were doing our fractions, we saw this device that looked like this. We might have 3/5. If I wanted to convert that into a percent is always out of 100. So if we read that as 3 out of 5, our percent is going to be out of 100. And to find the missing number here, we developed this process, or we recognized this shortcut, where we could cross multiply and divide. To cross multiply, there's always two numbers that are on a diagonal. The 3 and the 100 are diagonal to each other here. So we multiply 3 times 100 is 300. And then the number that's on the other diagonal by itself, we divide by. So we divide by 5, which gives us 60. So this is 60 out of 100, or 60%. We talked a little bit about benchmarks. If we had 3,200, if I wanted to find 10% of 3,200, that's 320. Oops, space. 320. 1% would be 32. And we could actually construct a lot of our percents just from those benchmarks. If I wanted 23%, I could just do 2 10s and 3 1s. So 2 10s would be 320 and 320. I could also just multiply by 2 if I wanted to. And 3 1s will be 32, 32, and 32. Again, I could have taken 32 times 3. And I'm going to get 736 is 23% of 3,200. Well, today we're going to look at, rather than doing benchmarks and having to add up different combinations like that, because some of you may have looked at this very differently. You may have looked at that and said, okay, I can find 25% because it's 1/4, and I'm going to subtract 2 1% from it. Or maybe I don't know what you do. There's other ways you can combine that anyway. The benchmarks is just mainly a way of estimating. But today we're going to take a look at how do you calculate these percents exactly. If I give you something like find 35% of 80. Well, we know that the percent is always out of 100. So in these problems, I always start with the percent. 35% is 35 out of 100. Now on the other side, we have to match things up. The 35 represents what's called a portion or a part. That is a piece of the whole thing that we're focusing in on. There's a whole group of stuff out here, and we're focusing in on just a little portion of that. The 100 then is the whole thing, or the beginning value, starting value. So now up top, we've got two other numbers. We've got the 80, and we've got the number we're trying to find. One of them matches up with the 35. It matches up with that piece we're focusing in on. The other one matches up with the 100. It is the whole thing, what we're basing this out of, or what we're taking it out of. The 100 is also sometimes called a base. Well, if we look at this, find 35%. That's telling us that the number that we're trying to find matches up with the 35%, 35. Of 80, we can think of that as saying out of 80, which implies the 80 has to go on bottom. And now this is just like our problems before, converting fractions to percents. We can cross multiply. 35 times 80 is 2,800. Divided by 100 is 28. So 28 is 35% of 80.
Could you reduce and then cross multiply?
You could, but with calculators it really doesn't matter. I'm just adding another step where there's a potential for error. So what if I have blank is 130% of 60. Oops, I wrote 30 of 60. So again, this looks a little bit different, but we have the percent. 130% is 130 out of 100. On the other side, we have the 60 and we have the blank. Which one matches up with the 130? Blank is 130, right? So the missing number, the blank, matches up with the 130. Again, it's of 60, so we can look at that, read it as out of 60. So 60 will go down here. So 130 times 60, 7,800, divided by 100 is 78. So 78 is 130% out of 60. Now, if you look at this, the piece that we're looking at, the portion that we're focusing in on, is bigger than the whole thing. Why is that? Yeah, it's 130%. 100% would be the whole thing. Anything bigger than 100% has to be more than the whole thing. So it makes sense 130% will be bigger than what we started with. We might have 70% of 90 is blank. So again, worded very different, but actually pretty much identical problem. 70% is 70 out of 100. We have the 90 and the blank. Which one matches up with the 70? The blank. If you read it this way, 70% is blank. That missing number matches up with the 70. And again, of 90, you can read it as out of 90, implies the 90 has to go on bottom. So now we cross, multiply, and divide. 70 times 90 is 6,300. Divided by 100 is 63. So 70% of 90 is 63. Or 63 is 70% of 90 if you wanted to change the wording around. This one's worded a little different. 42 is 60% of blank. So we have the percent still, so 60% is 60 out of 100. We have the 42 in the blank. Which one matches up with the 60? Yeah, 42 is 60%. Of blank, we can read that as out of blank. Implies the blank goes on bottom. Cross, multiply, and divide. 100 times 42 is 4,200. Divided by 60 is 70. 42 is 60% of 70. Any questions so far? %20 of blank is 36. So again, we'll start with the percent. 20% is 20 over 100. Of blank, you can read that as out of blank, implies the blank goes on bottom. 20% is 36, implies the 36 goes with the 20. And again, we cross, multiply, and divide. Notice we're multiplying in a different direction. Before we were multiplying down, now we're multiplying up. It's just whatever two numbers are on the diagonal with each other. So 100 times 36 is 3,600. Divided by 20 is 180. So 20% of 180 is 36.
If you know that 1/5 is the same as 20%, could you multiply 36 times?
Yep. Yes. If you see those patterns, yes, definitely. How about this one? $28 is blank percent of 70. All the problems so far I've been saying we start out with the percent. But here, we don't have the percent. That doesn't change anything. We're still going to start out with the percent. We're just going to put in blank over 100. Now, 28 is blank percent. That implies the 28 matches up with our missing percent. Of 70, if we read that as out of 70, that implies the 70 goes on bottom. And we're going to cross, multiply, and divide. 100, and again, notice we're cross multiplying, we're multiplying the same diagonal, but the number we're dividing by is in a different spot, but it's still cross, multiply, and divide. 100 times 28 is 2,800. Divide by the 70 is going to be 40. So 40 out of 100, or 40%. 28 is 40% of 70. Or we might have blank percent of 30 is 48. So again, we're missing the percent. Blank percent is going to be blank out of 100. Of 30, it could be read as out of 30. The 30 goes on bottom. Blank percent is 48, so that implies the 48 goes with our missing percent. And we cross multiply and divide. 100 times 48 is 4,800. Divide by 30 is 160. So 160% of 30 is 48. Now, as we look at these, there is another way of doing this. The way I was taught, now I like this proportion because this proportion is always the same thing. Once you get the numbers in there, you're always going to take the two numbers that are diagonal, you're going to multiply them and divide by the third. Calculation is always exactly the same. But there is something called the rate method of percents. If you use the rate method of percents, you change the percent into a decimal. And let me show you what I mean. 35% is 0.35 as a decimal. So for this problem, you would take 80 times 0.35 and get 28. Well, that seems pretty simple. It gives us the same answer. Let's keep looking. The next one here, 130% is 1.3. You would take 60 times 1.3 and get 78. Well, again, that seems really simple. So why don't we use the rate method? Well, I do. When I calculate, I usually do use the rate method because that's how I was taught, and I'm pretty quick with it. And it is a little bit quicker. But one of the problems with the rate method is, you can see here, we turned the percent into a decimal, and then we multiplied. But if I move down to this one here, 60% is 0.6, but it's not going to be 42 times 0.6. Here it would be 42 divided by 0.6 to give me 70. So with that rate method, you have to figure out, do I multiply by that decimal or do I divide by that decimal? Like this one here, 20% is 0.2. It would be 36 divided by 0.2 to give me 180. Then there's a third type. This one here where we don't have a percent. You would divide 28 divided by 70 is 0.4. Then you would move the decimal to make it a percent, so 40%. So if you want to use that rate method, it is a little bit quicker. It takes less paper, but you do have to be able to figure out, do I multiply, do I divide, or do I divide and then move the decimal point to make it a percent? So it's a little bit trickier. Whereas with the proportion, once you get the numbers in there in the right spot, that's the only tricky part, is making sure the numbers are in the right spot. It is always cross multiply and divide. The calculation is always exactly the same. I also like the proportion for once we get to your word problems, and I'll show you that in just a few minutes. For right now, I want you guys to try a few in your notes. So I'm going to give you 36 is 90% of blank. 57 is blank percent of 190, and blank is 30% of 7. Do those three in your notes quick. So for the first one, 90%, 90 out of 100. Where does the 36 go, top or bottom? On top. Cross multiply and divide, we get 40. 36 is 90% of 40. How many of you had 40? Good deal. Any questions? Okay. Blank percent, so blank out of 100. Which one goes on top, 57 or 190? 57, so the 190 is on bottom. If we cross multiply and divide, 100 times 57 divided by 190 is 30, so 30%. 30% is 30 out of 100. Where's the 70 go, top or bottom? Bottom. Cross multiply and divide, 30 times 70 divided by 100 is 21. Anybody have all three right? Anybody have questions on how to do them? Okay. Now, as I mentioned, I like these proportions for word problems. Because when I start doing word problems, the proportions make things a little bit easier. For example, let's say that taxes are 28% of gross income. How much does Pete pay in taxes in a week where his gross income is $950? So just like in the other problems, I always start out with the percent. 28% is 28 out of 100. Now, before I do anything else here, I'm going to label what that means. 28% represents what? Taxes. And that's 28% out of what? Out of gross income, which means the 100 represents the gross income. That's what this percent is based off of. The 100 is always representing the item that this is out of, or calculated out of, the whole amount. So now on the other side, the 950, does that represent the taxes? No, does it represent the gross income? Yes, it does. So now, are we looking for the taxes? Yes, how much do you pay in taxes? So we'll cross multiply and divide. 28 times 950 divided by 100. 266. So Pete pays $266 in taxes during that week. Now this, making these little labels on a problem like this doesn't necessarily seem terribly useful, but in a problem like this it can be. LMNO Corp estimates gross profits as 12% of net sales. What were net sales during a week when gross profits are estimated at 12%? 38,400. So here we have our percent, 12%. So 12 out of 100. What's the 12 represent? That is the gross profit. And the gross profit is calculated out of what? Out of net sales. Very good. So the 100 represents net sales. So over here on the other side, we have the 38,400. Does that represent gross profit or net sales? Gross profit. So 38,400 goes on top. Now the bottom would be net sales. Are we looking for net sales? Yes. What were the net sales? So that is what we're looking for. Now it seems silly to ask that, but I'm going to show you a problem, an example here in a little bit where that makes a big difference. So we have 100 times 38,400 divided by 12. Should give us 320,000. What do you think? Not horrible? Well, then let's look at a problem like this. Tim pays 24% in taxes. How much does Tim take home in a week where his gross earnings are $820? So we set this up. 24% is 24 over 100. What does the 24 represent? That's the taxes. Exactly. The 100 represents gross earnings, the whole amount. Now we have the 820 here. Does that represent taxes or gross earnings? Gross earnings. Are we looking for the taxes? No, we're not. We're looking for how much does he take home. But if we know the taxes, can we use that to figure out how much he takes home? Yes, we can. So we can go ahead and do this. 24 times 820 divided by 100. Yep. $196.80. Now we're not going to add it to the 820. The 820 minus the 196.80, because we're going to subtract the taxes out of it. So I'm going to borrow from the 2. This will be a 1, 10, borrow again, 9, 10, borrow again, 9. Oh, I don't need to borrow again, sorry. Let's leave this as a 10. So 0 minus 0 is 0. 10 minus 8 is 2. Bring down the decimal point. 9 minus 6 is 3. Borrow from the 8. That'll be a 7 and 11. 11 minus 9 is 2. 7 minus 1 is 6. So he will take home $623.20. So we found the taxes, but we had to remember that that's not what we were looking for. We had to take the taxes out of his gross paid. We wanted how much was left over after the taxes were taken out. Does that make sense now, Scott? Yeah. Okay. Let's say that parts for a job cost $210. Francis adds 15% for handling. How much will Francis charge? Not enough? Well, we've got the 15%. The 15%, the 15 represents what? How much he adds for handling, right? We'll get to that. Hang on to that. The 100 is the original cost. That's the starting amount. So that's going to be cost. Now I have underlined it so we know that the 210 obviously represents the cost. Are we looking for the amount of handling? No, we're looking for the amount that's charged. But again, if we know the handling fee, we can figure out what was charged. We cross multiply and divide here. 15 times 210 is 31,500. Divided by 100 is $31.50, right? So, how are we going to get our answer from that? Yeah, this time we're not subtracting them, we are adding them. Because he's adding 15%, not taking an amount away. The taxes take them an amount away. At here we're marking it up. We're adding that amount to it. So $241.50 is what they would charge after they mark it up.
So technically, wouldn't it only be $31.50 because it doesn't say that Francis is selling the parts as well? It just says he's adding 15%.
Yeah, that's a technicality in the wording. Yeah, I may have worded that a little poorly. Okay, let's do this. After a 7% discount, Pat pays, let's see here. $9,486 for supplies. How much did Pat save? So now here, 7% discount. 7% does represent the discount, right? The 100% represents full price. Now here, we're looking for the discount, right? How much did Pat save? That's the amount of the discount. That's what we're looking for. Does the $94.86 represent the full price? No. That's after the discount. So looking at this, we have a little bit of an issue here. That does the 94.86 does not represent the 7 or the 100 in this problem. Well, when we're dealing with percents, there's always another percent hidden in the problem. It depends on whether it's added or subtracted, but it always goes from 100. It's either up from 100 or down from 100. Here, a discount, is that added or subtracted? That's subtracted. So 100% minus 7% would be what? 93%. So in this problem, 93% might come into play. So if we write 93 over 100, or 93%, the 100 is still full price. 93% represents the price after the discount. Now, neither one of those is what we're looking for. But if we knew both of those, we could find the amount of the discount, couldn't we? And we have the $94.86, which is the price after discount. So we can cross multiply and divide 100 times 9486 divided by 93 gives us 10,200. So the price before discount was 10,200, but that's not what we want. We want to know how much did Pat save. So 10,200 minus 9,486. This will be 9, 11, 10, or sorry, 9 and 10. So we've got 4, 1, 7. $714 is what Pat saved. That was Pat's discount. Does that make sense? So after a 20% markup, Stacy charges $384 for a part. Assuming that the whole markup was profit. What is Stacy's profit? Why don't you try that one in your notes quick? So first of all, we have 20%. 20 over 100. 20 represents the markup. 100 represents the original price, right? Do we have either of those amounts? No, we have the amount that Stacy charged for these parts. We don't have the original price. So now what we're going to look at, we have the 100 and the 20. Does the 20 get added to the 100 or subtracted?
I added it.
It's a markup, so we're going to add it. So we're looking at 120%. So let's look at 120%. Now the 100% is still the original price. That does not change. The 120 is what Stacy charges. So now on the other side of that, 384 is what Stacy charged. Now the original price isn't what we're looking for either, but if we know the original price, we can find the profit. We can find that dollar amount of the markup. So 100 times 384 divided by 120 is $320, right? So that means 384 minus 320 is a $64 markup. That is what Stacy's profit was. Does that make sense? We will talk more about those percent increases and decreases like that next class tomorrow. I'm looking at possibly getting to your unit test on Thursday. It depends on how the discussion goes. There's a lot of material and what I have planned for tomorrow. It may take 2 days to get through it. So at the very latest, your unit test will be next Tuesday, your unit 2 test. But possibly this Thursday if things go well tomorrow. Unit 2. So in your book, page 84 through 89, 1 through 53 the odds.